So just to remind you guys, it's always at some point somebody's not realizing this, but everybody understands I'm recording this. There's a link in Canvas if you want to watch the video. You can slow me down, speed me up. I kind of like it because then you don't feel like so beholden to try to capture every word I say, right? You can go back and watch them. I try to do a better job now of describing what the video is. When I first started doing this, it was blank, so now I'm like, I have no idea. But I've done it since 2011. I'm basically a YouTuber with a very small set of subscribers, which is fine with me. Any questions specifically from the homework? Besides, I'm going to talk about these here in a minute, but anybody have any specific questions from the homework? Yes?
Kind of. So on the first one,
Which one, sorry?
but it's the question about the age patients and the clinical trials.
1 through 5?
Yeah.
Okay. So often statistics is not analyzing things that are good, but here we have these two researchers following a different group of AIDS patients. And I always get somebody that just gives me definitions here. No, I'm never going to ask you a straight up definition question. What is the population in this situation and so forth, right? Did you have a specific problem with one of those, or?
Yeah, so for the population, I put all AIDS patients.
Sure.
Right, everybody that has AIDS, which is a lot, I guess a lot of people. For the sample, is it correct to say symptomatic AIDS patients that are enrolled in the study? Or is that not?
Well, all right, so I was going to say, there's a little more specific, because the way they kind of put this out there is once the AIDS symptoms have revealed themselves. So I would accept either all AIDS patients for the population or all AIDS patients where the symptoms have revealed themselves.
Symptomatic.
One of the two, to be honest.
So that's confused you off.
Yeah. Your sample, you can be very specific about your sample, because we know, and how specific, just, I know how many, don't I?
20 out of 40?
Yeah, because we're only talking about one of the researchers, right?
Yeah.
So 20 AIDS patients, that's the sample.
Okay.
What's really interesting is, very often when you write the population, if you just replace the word all with the number, bang, because they both reference the same group. Just one of them references the entire group, the other one references a subgroup. So they're going to sound almost the same. One of them's going to say all, the other one's going to say a subset. So, you guys all with me on that? Does that make sense? Some of you guys are looking at me like these worried eyes, but you're like, sure, I understand. Didn't know what you're saying right now. Okay. Anybody else have any trouble with this one?
So the parameter would be what on this one?
So listen. Okay. Parameter is a numerical description of the population. It's almost always, especially at the beginning, so let me just say that, for us right now, it will always be an average, or more accurately, a mean. Right? So when you see the word mean, it's the same thing as what we think of as average. It's either going to be a mean of the population, or it's going to be a percentage or a proportion of the population. So it's the calculation I make once I get all the data.
So should it be a numerical value? Like, do you want us to?
No, if they don't give us a numerical value, they didn't ask us to calculate it. You just have to identify it. So it would be the mean. So just to give something away, the population was all AIDS patients. The parameter then better include that phrase, because it's supposed to describe the population. And what does it describe about all AIDS patients?
The average length of time.
Average length of time in months they live once they start the treatment. Right? So the average length of time in months that all AIDS patients lived once they started the treatment. Okay. Because what are we trying to figure out when we're trying to give? And have you guys heard that the mRNA vaccine kind of stuff, the whole thing has led to the first trial of an HIV mRNA vaccine? Have you heard that? They are starting human trials of mRNA mRNA vaccines to protect against HIV, right? So I wouldn't necessarily phrase it like one good thing that came out of COVID, but one good thing that came out of the research that was spurred along more because of COVID is using mRNA kind of stuff for other things. If you're anti-vaccine, keep it yourself. I don't want to know about it. Just learn more. Okay. What was I saying? Blah, 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 blah. Is that all right? Did I finish my thought? I'm off on a tangent. You're all like, I don't even remember, dude. All right. Any other questions about? Yes?
Is there like a specific due date for all chapter 1?
So here's how it works. The homework is not late until you turn it in after the test. You could technically give me all chapter 1 and 2 homework on the day of the chapter 1 and 2 test, right? And that's on the homework sheet, right? I would much rather that as you get a section done, you turn it in. Just as you get them done, turn it in. How do you know if you're on track so you're not like behind? You should be ready to turn in the section a week after I finish lecturing on it. So we finished 1-1 for sure. Can't remember if we finished 1-2. So you should be able to turn in like those 2 possibly on Monday. Some of you guys are going to turn some in today. So getting ahead is a really good freaking idea. Yeah.
When we turn it into, you're gonna mark which ones are wrong, and then how quickly in advance do you usually give the homework back after?
If you give me the homework before the review day
Okay.
for the test, so whatever the test day is, the day before, the class before is the review day. If you give it to me before that day, I will give it back to you on that day at the latest. So then you have it to study for the test, right? Because that's homework's job, is to get you ready for the big bad test.
And then you said we made corrections, and we turned in those corrections?
Yes, what are homework corrections due?
The day of the test.
They're the day of what test? The final.
Okay.
What's due on the day of the test is homework, is quiz corrections. So remember, if I were you, I would have a little copy of the syllabus with me all the time. The one shirt I have, so I haven't worn any of my math t-shirts yet, but I will, especially next week when it's freaking 90-something degrees. But I still don't have the one that says it's in the syllabus. I need that one. I have the one that says, show your work. But, all right, so, anything else specific before I get into that one section that I know you're gonna need help with? Anything else? All right, so here's the section I'm talking about. This section right here. Oh crap, that's fine. All right. It's a little bit weird what it's asking you to do because it feels like it didn't give us enough information. But that's why they say give examples where appropriate. So let's see. Oh shit, I wish I would have looked. I think 43, I didn't assign 43, did I? I don't think so. Okay, so let's talk about 43. So don't do too much of your homework for you. So what I need, somebody will turn this in and they'll have 42 is E, 43 is B. No, each problem you have to answer A through F. Each problem, A through F, you must answer, right? So let's do 43 for example. What's the population in number 43? So what is a population in general? It's a, yeah, it's all things I want to say something about. So am I talking about dogs? Am I talking about length of skis? Am I talking about what things am I talking about? Kids, I'm talking about children. So the population is all children that have taken their first ski lesson. Does that make sense? It can't be all children, because then some of them don't even know what a ski looks like, right? Okay, I like it. You guys all with me? Yes? Okay. The sample then is where you could be specific if you want to. You can make some shit up. This is where you can give an example. So you could say something really boring like, the sample is a subgroup of all children that have taken a swim. All right, that's technically right, and that's fine. Now, the other thing you could do is not that exciting, but you could say, 87 randomly selected children that have taken their first snowboard lesson. So let's do that. Right, let's say that our sample is 87. Do I want to write this down? And then I have, no, screw it. So the population is all children who have taken, what is it, ski lessons? Ski and snowboard, dude. Yeah, I can't ski, but I can snowboard. I don't know what it is about skiing, but I guess I suck at it. Okay. Then our sample could be 87 randomly selected kids who have taken the ski and snowboard lessons. Okay. All right, I like it. Where did 87 come from?
Random.
Yeah, I just made it up, right? That's what they mean by give examples where appropriate. So you're kind of telling me what could a sample be. You could even, people have even gone really crazy and said, like, giving me more specific ways to pick them. You know, but you don't have to go that. Now, what about the parameter? What is it that I want to say about these kids?
You're looking for the mean age.
Good. The parameter is the mean age. But to fully answer it, I've got to say that about the population. Right? So I've got my population written, which means this better show up in my answer for this. The mean age when all children who took the lesson, the mean age when all children took their first lesson. So you got to make sure that it references the population that you've written. And then the statistic is the same way with the sample. All right, so the statistic would be, what would this statistic be?
Mean age of the 87.
Yeah, mean age when the 87 selected kids had their first, right? Mean age when 87 kids had their first. Okay.
So you're really only swapping the all and the actual number kind of?
It almost always works. Be careful. It doesn't always exactly work. You gotta, make it make sense English-wise, grammatically. But most of the time that'll work. It's just swapping those out. Because that's it. The reason it works is because that's what the freak it is. They're both groups. One is everybody that does this thing or is from this place or whatever, and the other one's a subgroup of the people that are from this place or did this thing. Okay, maybe. And then the last couple, the variable. What was the variable related to? What do I do when I get these people together, these little kids? What do I ask? Maybe their parents, I don't know. Depends on how old they are.
How old
Yeah.
are you?
Yeah.
How old were you?
Yes, that's the question. So what is the variable? The age of the children when they had their first snowboard lesson. I really want that. That's the variable. Okay. So see what I mean when I say it's related to the question. The variable is related to the question. The data is related to the answers. So I have a group I want to say something about. I get a group I can handle. I have a thing I want to be able to say. Here's what I can actually calculate. Now that I got my group together, I'm going to ask him a question, right? Age of child at first lesson. And then, the only way to answer this question is to give example answers. That's the only way to answer the question about what the data is. If you describe the data, you're answering the variable question. So what's the answer for the data? 12. 7. 3 months. Okay. My mom skied with me when she was pregnant with me, and I picked it up through osmosis. Oh, I can feel that. All right. I don't know. I'm not advocating an experiment for that, so just in case. Okay. Is that better, guys? Are you guys feel better about what's expected here?
Yeah.
So a few of those are completely up to you. You can be creative with it, whatever. Okay, I like it. The answer to the parameter and the statistic will always either be a mean or a proportion, and you notice how each problem tells you which one it is. It's crazy. Okay. Anything else from that we've done? Okay. So today it's going to be so exciting. We're going to do more definitions. Yay! So not yesterday. You know, we finished with nominal ordinal interval ratio, correct? If I remember correctly. Okay. So today we're going to pick it up with. Holy crap! What happened to you? All right. Today we're going to pick it up with different sampling methods, different ways to get a sample. Let me experiment here a little bit. There we go. Well, that works. Okay. All right, I'm going to erase this here. You ready? Okay, so we did discrete and continuous. You guys remember that? And then exciting nominal ordinal ratio. We did quantitative, qualitative. So many words. Shit. So here's the last set of words. Types of sampling. Or sampling methods, or however else you want to say that. You guys see that green?
Yeah.
Everybody? Okay. What sucks for teachers when we leave one of these in a room, I'm like, well, that's gone. Shit. So I lost my black marker. All right, so the gold standard for any sampling method, and what I mean by that, I really want you to understand, the way that I choose my sample is important. We talked about that a little bit on Tuesday. That's the day it was. When we talked about how you guys are a bad sample, right? Not because you're all bad people, but because we're all this bias points. Remember that? Okay, I like it. I like it. So what are some? So the gold standard for any method of sampling is to be random. To be really honest, it's sort of a higher level than that. But we'll start with this. Did we discuss what it takes to be truly random?
The unbiased.
True, but how do you try to get bias to not show up? How do you try to avoid bias? Remember I said it had to be representative of the population? All right, let me say this. Why would it be bad if I collected information on people, what if we voted for president by getting something out of a Gentleman's Quarterly magazine that we had to get, and then we send it back in? Would that be a good way to vote for president?
No.
Why not?
Because there's only specific people ordering that.
Yeah, does everybody get Gentleman, is that even what I'm thinking about, Gentleman's Quarterly? I don't know any magazines, shit. So, does everybody understand? So the fundamental way to try to make your sample come out with as little bias as possible is to make sure every element of your population has an equal chance to be chosen. Let me say that again. Every element, what letter is that? In your population must have an equal chance of being chosen. Come on. So if I put everybody in here, had you write your name on a piece of paper, and then I checked them to make sure, I'm trying to think about anything else that could go wrong, and I put them in a hat, and I picked one person, is that a random selection?
That's right.
Yes. Now I love it if anybody was like, well, what about if somebody had a really long name, the ink is heavier on that paper, and they go, no, I screwed it all up, and I did everything right. Okay. That is random. There's no other thing. That's just pure random. Everybody had a chance that was in the room that day. That would be my population, right? These other things have systems on top of that. They still want to be random, but they're kind of more systematic ways. And what's funny is systematic is one of the types, so I might as well talk about it. There's a type of sampling called systematic. Jeff. Every time I talk about this in my head, I'm going systematic, automatic. What do you think that might, that's kind of like wide open. There's going to be a system to it. So here's how it works. What if I went out, took a temperature every 10 minutes? There's a system to how I'm collecting the data. What if I took grass every 50 feet to analyze soil samples or whatever, the grass samples, right? What if I took the sound level every 3 hours or something, right? Every nth something. That is the fundamental part about what systematic is. You guys doing okay?
Yep.
Some of you guys, all I can see is your eyes, so some of you guys are like, yeah. Does that look good? That's a little scary. Okay. Every nth thing. Hopefully you understand what it means. So it could be every nth minute, every nth person. What's nth mean? Fifth, sixth, seventh, second? I don't know. Could be anything, right? Okay, I like it. So if I randomly pick somebody here, you, and then every fourth person after that I picked, that would be systematic. Okay, I like it. If I do that, did everybody have a chance to get into the sample? Who did not have a chance to get in the sample? So I randomly pick somebody from this section here, randomly pick somebody, and then I start counting every fourth person from them. Who did not have a chance to get in the sample?
The person who got skipped from the system.
Say again?
The person who got skipped from the system.
Did they have to be skipped? So here's the problem. Some of you guys think about the end sample and say, some people ain't in there, so it's not good. Some people are not going to be in the sample, correct? So that's not an accurate way to ascertain if that was a good random sample. If I randomly pick the first person I start at, couldn't anybody end up 4 away from that person? Some multiple of 4? If I randomly pick somebody and then start counting 4 from there, everybody had a chance. Correct? You guys understand that? Some are not going to be in the sample. That's not the purpose. Otherwise, we just always take everybody and go insane trying to do that. Right? Okay, maybe. Okay. Then you got these two. There's two that kind of go together. One is called stratified, and one is called cluster. Okay. These kind of suck for students to remember because they both have the same first step. Both of these break the population into groups. So they both have, so I always envision like 3 classrooms. It could be at a high school, it could be freshmen, sophomores, juniors, seniors, right? In an area, it could be zip codes, right? I've broken the population area down into people in zip codes. The second step is what distinguishes these two. All right. Stratified. Oh, you guys are loving this shit. I know. Don't worry, we're almost out of the definitions. Stratified is when it takes some from all. Stratified takes some from all. Sounds very Three Musketeers-ish. I take some from all to be in my sample. Some from all. So, for example, you guys are naturally broken up into rows, right? You with me? You are the king of that row. And nobody else in that row. So if I randomly pick 3 rows, oh sorry, I'm thinking about cluster. If I take from each row, I take one person, that is stratified. Did everybody have a shot to be in the sample? Yes. Everybody has a chance to be in the sample. I like it. Okay. So I really want you to understand, this, if done correctly, is random. Why is my answer not random for this? Because it has a little extra to it. It's got a little extra method to it. So when will my answer be random? When it's just names in a hat or a number generator or something like that. Okay, I like it. So what the shit does cluster do? Probably the second thing I started saying earlier. Cluster takes all from sum. So that would be where if I just randomly select 3 rows and I take all the people in those rows. Now here's where people sort of disagree with me, but is that random? Does everybody have a chance?
Yes.
Of course everybody had a chance. Everybody's in a row, correct? Even the people at the tables, I would put you in a row. You're all in a row. So if I randomly select 3 rows, everybody had a chance. I love it. Again, don't let yourself think about the end result. You go, well, I didn't get in there. Nobody called me, right? I still don't like that. I've never been called for all these phone calls. I'm like, I don't know about her. I don't know. All right. So these are the good ones. These are the good ones. Real quick, timely example because of everything happened in Afghanistan. One semester, I had a student that was a veteran who had fought in the Iraq War. And he said, and I talked about the fact, he said, that's right. He said cluster is shit. I think he said exactly that, or something like that. I was like, neat. I'd never had a student with strong feelings about this. And he said something about there was a report that was done and it was bullshit about stuff. And so I said, I'm going to have to look into that. So I researched it, and they had done a report not long after the fall of Baghdad. They sent people in to see how the neighborhoods were doing. So they broke it up into areas, right? You with me? They broke it up into areas. It sounded like it could be one of these two. And then they went in and talked to everybody in those areas, right? Or something I can remember. So it was clustered. But they broke it up into areas and they said, oh, that place is bad. And so is that place. Let's not go to those places. Let's pick some from over here. Is that random?
No.
Isn't that biased? Isn't the report going to sound better than it really is? So I can understand why this student had a strong reaction to this, right? But I'm glad that eventually he understood that the people who did it were the ones at fault, not cluster method itself, right? Okay, I like it, maybe. All right, and by the way, if anybody has anyone in Afghanistan, I feel for you. Hopefully it's all going to come out better. Everybody understands what's happening around, do you? I'm almost jealous in a sense if you don't, but maybe stay up with current events, but I think everybody's. Okay, the last type. These are all the good ones. I already said this, I think. You guys, you guys remember what the name for you as a sample was? You were very easy to get a hold. You're all right here, so it's really convenient. Good. So convenience sample is the 5th. And it stops. Let me see if you understand this. I could follow one of these methods perfectly, and my sample could still be shit, and I wouldn't know it. I really want you to understand. This is the thing people don't understand about random. I could do a convenience sample, and it could actually be beautiful. It could represent the population perfectly. Would I know that? No. So if you don't make an attempt to have a truly random sample, I have to ignore your results. I have to. So what happens in science when somebody makes a discovery? What's the very next thing after they send it in for peer review? Do you guys know what happens next? So if I had a team and we discovered something and we reported about it, other teams, many other teams would try to replicate it, right? I don't know if you guys are with me at all. You're all like, What does this have to do with anything? So if I did a study and I found something, other groups are going to try to do the same study with their own samples to verify what I found, because I could have done exactly perfectly what I need to do, and randomly just happened to get a bunch of people that were young if I was trying to do the age thing, right? It's not impossible for me to pick randomly 80 people and they're all younger than the average age. So any analysis I do is off. So you don't accept it until it's been replicated. Do you like it? And unfortunately, news sometimes runs with something before it's been fully verified. That used to happen all the time with food. One week, eggs are good. The next week, eggs are bad. The next week, eggs are good again. Yeah, and drink some wine with that. Not too much. Well, no, it's okay. Anyway, sorry. I mean, nobody lived through that? No? Yes? No? You're all like, what the shit are you talking about? All right. Eggs and wine? No. I'm not an egg guy anyway. All right. No, you can have all my eggs. I hate eggs. All right. They're food glue. They're for making cakes. So all the eggs you eat are all these unmade cakes. It's just, all right. That is the end of the definitions. Thank the gods. So what we're about to do, what time is it? Okay. Is we're going to transition into section 1.3 is interesting. It has some numerical analysis we can do, some data stuff we can do. I don't know if you guys have tried this out yet. Frequency tables. So one thing we're going to do, not today, I don't think. I thought maybe we would do this today, but maybe not. Have you guys got calculators coming? Does everybody have a calculator? Everybody understand you need to have a calculator? Either, a TI like this, big fat boy, or again, a little skinny boy, right? Or, even whatever, in the middle, I don't know what it is. So a TI 83, 84 calculator. Somebody went and got one. I like it. So they have them in the library. Yes. You can check them out in the library. You can use them in a study center. Okay. I might do something with this today. We'll see. Oh, your battery's dead. All right. Fantastic. All right. This is one of the most basic ways to represent your sample of data. Right? So what the hell does this mean? What does that 3 mean? Yeah. 2, how frequently did 2 show up 3 times? So we call it frequency because we're crazy. I like it. Now I could add one more column here and make it a little more interesting. Can I do that? No, I can't. Yeah, gum it. I'm too used to being at home where I could draw on shit. I'm drawing on you. No. Well, you saw. All right. I could add another column and make what's called relative frequency. Relative frequency. Does anyone have any idea what that would be? Yeah.
So you take the frequency, divide that by the amount of
Yes.
20 students with.
How many data points are there?
There's
20, right? 20 students.
two.
Everybody with me? And sure enough, if I add these up, they better freaking add to be 20. So when you do this kind of table, take a second and make sure these add to be the total number of things and people or whatever it is. Okay, I like it. I like it. What percentage of the data are 2s? 3 out of 20. Multiply by 5, 15 out of 100, 15%. There it is. You guys with me a little bit? Is it just hot to me or is it hot here?
That's pretty much.
It's warm? I don't even know how to control that. And so you can do that all the way down, and of course, and there's a fan back there. Oh, I don't think I can control in here. We're just gonna deal with it. What should all the percentages add up to be?
100%.
100%. They won't. Why not? Why would they sometimes not add up to 100%? Do you think when you're going to write that down, do you think you're going to put all the decimal places? Now this one it would, because the bottom is 20, so they're all going to be nice whole numbers, right? But what if there were 17 people? 3 divided by 17 is not something that's going to end anytime soon. So when you round it, you could round more up than down. So your number could be a little more than 100 or a little less than 100. Okay, all right, I like it. The next, so this whole thing, let's do this. This is going to lead us into chapter 2 also. All right. This is going to be so exciting. I'm going to make up some numbers. Yay. Oh, okay. We need like Etch-a-Sketch things. I can just push a button and it goes. So I'm going to make up some data, and I'm going to turn this dude around. And we're going to create a frequency table. Yeah. That's great. Sure, I'll just do the order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, of course. 11. So obviously this is easier than that because this is in order. One of the first things we're going to learn with the calculator is how to make it put data in order. Okay? Calculator should just eat that up, especially because it costs $100. Better be able to put my list in order. So I've got my data points. I got my freak and my real freak. Frequency, relative frequency. So what's the frequency for 4?
3,
Yeah, it's crazy. 3, 5,
2,
2, 6,
4,
4.
1.
And there's 11 data points, and thank God this adds up to be 11. All right. Crazy. Now, this only really makes sense. Can somebody imagine what would the data list look like where this wouldn't make any sense to do this? What would the data list look like?
Didn't have numbers?
Okay, but I got numbers. So it's a list of numbers. What would have to be true about the list of numbers where this wouldn't make much sense? If none of them showed up more than once. Right? If my list of 4, 5, 6, 7, 8. Whoa. Now this at least tells me what? If this was ages of children in a playground, what can I very quickly tell? Most of them are 6. I can even see that most of them are 4, 5, or 6. Right? Okay. And of course, if I had a much larger set of data, this would be a much better short summary of it, right? And then the percentage is really the best. What's 3 divided by 11? 27. I like it. So we'll make that 27.3%. 2 out of 11.
Point, is it?
What is it?
Oh, wait. Oh, 2 out of 11.
Yeah, 2 out of 11, yeah.
I was looking at something else, my bad.
I thought I had gone crazy.
There you go, point 18.
Is everybody with me? 4 out of 11. And then 1 out of 11. Now you got it. Tell me if I'm wrong. I'm just trying to remember this in my brain. Is that right so far?
Yeah.
091, is that right?
Yeah, that's right.
And of course, I'm rounding to the third place. So another one of those. So if I add all those up, what do I get? So 5, 9, 10. It looks like I get 100.1. Is that right? 5, 9, 10. Yeah. Check me out. Is that true? Anybody help me out? You're on your own, math boy. Okay, somebody's giving me a little bit of a nod. Okay. I think that's 100.1%, and we now know that's fine because we rounded. So it could go a little off. Okay. Now, how do we graph this? Yes.
Real quick, so if it's under or above 100%, that's fine?
That's fine. If
Okay.
I would, no, there's no real hard, like, too far away line, but it should be at most 101 or at most 99, right?
Okay.
Even that's a little questionable. But if you're like at 97, you lost people. Or if you're at 104, you created people, which is neat. Yeah.
And then let's say the number goes on, so like 3 divided by 11, if that was 0.273333. You said you're rounding it, but
Yeah, I think it's 0.272727, right? Am I remembering that correctly? I could be wrong.
but you round in the third place.
Yeah, I'll tell you. So we'll develop some rounding rules.
Okay.
The reason I round this to 3 places is so my percent has 1 decimal place. Because we're about to graph this by hand,
Okay.
and I can't even get that precise, but yeah. Let me double check myself. Yay! All right. All right, you guys, everybody with me? Okay. See how I always check in with you? So feel free. I just want to say this. Maybe nobody has a question, but if you have a question, at least 8 other people have the same question. So don't hesitate to ask a question. I like it. So to graph this, I can do this. What was it? 8. So 4, 5, 6, 7, 8. I want this scale to be my percentages. So how high do I have to go? Jeff, it's okay. That's even worse. Okay. How high?
At least 36.4.
Yeah, yeah. So what should your scale be, do you think? I love you guys. Should I go by ones?
No. I
1, 2, 3, 4, 5, 6.
Maybe by 5 seems, maybe 5.
Let's
I don't
try
know.
5.
What do you think?
I don't know. 5, 10, 15, 20, 25, 30, 35, 40. It sounds good. But that's a consideration. So we're going to be graphing stuff. And dear God, if you just put 9.1, 18.2, 27, if you just kind of put the numbers down that are there, there's no guarantee that the scale is consistent. And that is the most important thing when you're making a graph, is to make your scales consistent, or else you're lying, right, to people. So this is my relative frequency. What did I say these were? Ages of kids
In a park.
in a park. And now I can make bars, right? You guys have all seen bar graphs. This is more of what's called a histogram. The difference between a bar graph and a histogram. So here's a bar graph. Democrats, Republicans. 10, 20, 30, 40%. Democrats, 30% of them said yes, and 7% of Republicans said yes. So whatever the shit the question was, I don't care. Right, so that's a bar graph. What's true about this data? What kind of data is this? One of the Q's. One of the Q words.
Qualitative.
This is qualitative because it's name data. What kind of data is this?
Quantitative.
Quantitative. So I don't want gaps on this one. This gap is fine because that's Democrats, Republicans. What does this mean? That doesn't mean shit. Doesn't mean Democrat and a half, right? Not in terms of how I was asking people this question. This means something. This means something. This means something. It's truly numerical. So if I had a gap, that's telling me that that's an empty area. Did I have any empty groups here? No. Every one of them had at least one kid in it, right? Okay, I love you. All right. So now I just make, my first bar is going to go how high?
27.3.
27.3. Right there. Pop. And then my next bar goes to 18.2. And then it goes 36.4, technically they should be the same width, but oh well. 9.1 and 9.1. So that's going to go. What are you doing over there? I don't know, Jeff. There we go. No, that's what it is, Jeff. You're silly. Okay. Sorry. So there will be problems in the homework just like that. Okay, I like it. Okay. Now, Jeff, you suck so bad. So unfortunately, all right, I actually have a worksheet from chapter 1 that completely slipped my mind that I haven't. Which is fine, because this is actually still technically chapter 1, so I feel better. All right. But to help you prepare for the first quiz, when is the first quiz happening? Does anyone know? You guys don't know, because I haven't told you yet. So I'm going to officially make the first quiz is next Wednesday, Thursday, a week from today. So feel about it as you will. But the way this works, I always pick my quiz days to match with when you should be done with the homework for that chapter or that thing. So we finished chapter 1, so you should turn in all of chapter 1 homework next Thursday, so you should be ready for a quiz next Thursday. Okay, all right. So this is sort of, kind of, a practice quiz in a way. That's cool. So what I want you to do is to kind of start looking at this yourself